In this first chapter of elementary statistics, we are going to go through an overview of what statistics is and also discuss some of the basic terminology. In the first section, we'll talk about statistical and critical thinking, and then later on, we'll talk about different types of data and collecting sample data. So let's talk about what data is. Data refers to collections of observations such as measurements, genders, survey responses, just as some examples. But in my opinion, we can summarize what data is by saying that data represents information. Now, information comes in all shapes and sizes. So data is information that can be structured in a certain way. For instance, let's say that this was a seated class and we actually saw each other in person. I would engage in a conversation with each of you, ask you some questions. I would get to know certain things about you and your life, and all of that information will help to get to know you better. But we can take bits and pieces of what I learned from you and call it data if I can organize it in a certain way. For instance, I can make a list of all your names, or I can make a list of your ages. I can make a table that compares your age to, let's say, the number of children that you have, if you're a parent perhaps. So data is nothing more than information that can be structured or organized. So then what is statistics? Statistics is the science of planning, studies, and experiments, obtaining data, organizing it, summarizing it, presenting and analyzing it, and then making interpretations so that we can draw conclusions. And sometimes what we learn from data, the conclusions that we draw, lead us to making certain decisions. And so it's basically the field where we look at information, we structure it, we just kind of look at it, analyze it, and see what the data tells us, and use how the data is informing us to draw some conclusions and then make some decisions based on those conclusions. A population. In statistics, we refer to the entire group that we are interested in as the population of interest. If I am gathering data about third graders at one particular school, then all of those third graders at that school would be considered the population of interest. So notice on this slide, the word all is in bold print. That's kind of the word you're going to be looking for. It's the entirety of who or what you are interested in studying. Oftentimes, the populations that we are interested in are too large to study in their entirety. And so we want to differentiate between a census and what a sample is. A census is when we're able to study everything or everybody in the population of interest. In the case of all third graders at one particular school, it could be that I can gather information from all of them, and so that would be considered a census of that population of third graders at the school. If, on the other hand, the population is much, much larger and harder to gain access to, for example, the population of the United States, then we resort to what is called sampling. A sample is simply a subset of the population of interest. So it's a group within that larger group that we are trying to learn something about. Let's look at this example. In a survey of 410 human resource professionals, 148 of them said that job candidates were disqualified because of information found on social media postings. And this is data that came from the Society for Human Resource Management. One thing I like about this book is that the author does try to use real information, real data, rather than manufacturing examples. So I like that there's a reference here to the source of where this information came from. All right, that said, so we have 410 human resource professionals. 148 of them said that job candidates were disqualified because of their social media postings. Let's see what they're going to ask us about this. Well, in this case, the population and the sample are as follows. We probably want to know something about all human resource professionals. Remember, it said in the previous slide that this was a survey, right? So these were the 410 individuals who responded to that survey. That doesn't mean that there's a total of 410 human resource professionals in totality. That's just who responded. So those 410 responses represent a sample of that much larger population that includes all human resource professionals. So in statistics, the goal is to study a smaller group, like a sample, study it closely, make some discoveries, and then try to generalize what we learn from that subset to the larger group, which is the population. So our hope is that what we learn from the sample can help us make some generalizations about what we believe is happening in the population at large. Statistics is a very large and complex field. Think about it. Information is everywhere. There isn't any type of information that can't be analyzed, that can't be organized. So statistics is quite literally everywhere. And there are a lot of professionals who devote their careers to certain parts of the statistical process. This slide gives us just an overview of the basic statistical and critical thinking processes. First, we have to prepare. We prepare for whatever it is we're going to study. So here are some questions about, in preparation of going out to study something. Once we go out and obtain the information, the next step is to analyze it. This is the step where we crunch the numbers and we manipulate them and come up with different summaries. And finally, once we kind of break the numbers apart, we have to put them back together, we synthesize it, and then we draw some conclusions. And those conclusions, again, our hope is that whatever we found within the sample can translate to some extent to the population that we're interested in studying. Let's take a moment to look at this example. We have a table that has some measurements on the length of shoe prints, and we have some measurements that refer to the heights of 8 males, 8, I'm assuming, adult males. So in the first row of this table, we have the shoe print measurements in centimeters, and on the second row, we have the height measurements in centimeters. Each column represents one person. So the first male has a shoe print of 27.6 centimeters, and he is 172 centimeters tall. Second column is for the next male, third column is for the next person, etc. This table helps us to start looking at the relationship between shoe print measurements and the height measurements. And I think if we just step back a moment, we probably have some guesses. Your guess may be, well, taller men may have longer feet and therefore have bigger shoes and therefore create longer shoe prints. That is a prediction, right? That's a guess. Organizing the measurements in this way can help us start trying to decide if that's what we're seeing. But I think you can see that having a table alone isn't going to necessarily confirm or rule out our guesses. So while we predict that there's probably a relationship, this certainly helps us to start trying to see the relationship, but we're going to need other tools to really see if that guess can be confirmed or if it can be completely ruled out. A huge part of being a good statistician is that you want to know where the information is coming from. I could argue all day that my height is 8 feet 9 inches. I can argue all day that I own 1,000 cars. And of course, I'm being ridiculous with my examples, but just because I claim certain information doesn't make it true or verifiable. So it's really important that as we talk about ways to look at data, that we always kind of back up a minute and look at where this data is coming from and perhaps how reliable we believe the data is. So looking at the source of this data, it does appear to be reputable, and again, our author and his team do a good job of finding real verifiable data for our examples. Another very important question to ask yourself as you are looking at data is how the population was sampled. If, for instance, I want to find out what Lake Sumter State College students think about bringing, let's say, a Starbucks to all the campuses. That's, by the way, I think a good idea. And I would love to know what the student body believes about that. I think it could make a very big difference if I say, hey, 100% of students in the sample said, yes, we need a Starbucks on the campuses. 100% of the students in our sample. Well, what if that sample was the 5 students who were in a little group talking to each other by their car? And so as soon as one person said, oh yes, absolutely, the other 4 kind of fell in line and said, oh yeah, of course. I don't think that's going to be the most reliable sample. So there are going to be different ways to collect samples, and some of them are going to create some very skewed findings by design. There are, however, some stronger sampling methods that at least give us a better chance of having that sample truly represent the diverse characteristics of the population that we're trying to learn about. So a very common sampling method is to put out a survey and ask people to respond. Those who choose to respond versus those who choose to ignore the survey or choose to not respond, they could have different qualities. When people respond to a survey, that's called a voluntary response sample. Why? Because they're choosing to participate, and others are choosing not to participate. Let's look at reviews, for example. I like Amazon because a lot of people shop on Amazon, and it just is a relatable example. When you shop on Amazon, you have the opportunity to go back and review your purchase. You can give your purchase anywhere from 1 to 5 stars. 1 star means you're very displeased. 5 stars means awesome, I got what I wanted. Maybe I got a little more. This is a voluntary response sample. Why? Because there will be people who purchase something on Amazon and don't ever go back to review the product. And so some people will respond and some people will not. When you have voluntary response samples, the results tend to be skewed to the negative kinds of feelings. For example, if I buy something through Amazon and it's exactly what I wanted, it came on time, I'm just going to say, okay, that's great, and I'm going to go on with my life. To take the time out to write a review or even click on, a link is just going to not be very urgent in my life. However, if I order something and what I got was nothing like what I was told I was going to get, and I'm very displeased with the purchase, I am much more likely to find a channel for my disappointment. I want people to know. I want to be able to let that disappointment out, maybe even a little rage. And so I am more likely to write a review, and in this case, it would be a negative review. So now that we've said that voluntary response samples are usually skewed and don't necessarily reflect the entire population from which those respondents came from, it's true that they're very, very common. And so as a student in this course, what's going to set you aside and apart from everybody else out there is that hopefully you're going to approach information, you're going to approach data, you're going to approach reports with a little healthy dose of skepticism, because I want you to think critically about where the data is coming from, what's the agenda for what is being reported. Of course, if someone is wanting to conduct a survey to kind of prove a point, they're going to find a way to do that. And so while surveys are very popular with internet polls, you can just click, 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 these are not going to produce the most dependable results. And there used to be a day where people would be hired to just make calls. People used to take telephone calls on their landlines, and those results were used for promotions, right? For commercials and advertisements for certain products. But hopefully you can see why this is a problem. If you are looking at a TV commercial, for instance, and they say 96% of everybody polled said that they prefer this type of, I don't know, fill in the blank, turkey meat, I don't know, milk. Who did they ask? When did they ask? Where were they when they were asked? All of these questions really matter. Here's a quick example of a voluntary response sample. We had a television poll where 186,000 people were called, and 67% of them said that the United Nations should be moved out of the United States. Wow, that's 2/3, right? A little over 2/3. So 2/3 of all the respondents said that they wanted the United Nations to be moved out of the United States. However, in a separate and independent survey, there were 500 people who were randomly selected and asked the very same question. And in this sample, 38% said that they wanted the United Nations to move out of the United States. So very different results. 38% is nowhere near 67%, and they were asked exactly the same question. I think this is a good example of how the sampling technique used could really make a difference in what you get out as data. 67% of 186,000 may seem like, wow, that's a lot of people. 186,000 people in a sample, that's huge. Maybe this is the more reliable result. Well, it's not just about the numbers, it's about the sampling technique. Whereas the 186 respondents were called, right? Some of them chose to not answer the question. Some of them chose to not answer their phones. They may have been led to a particular answer based on how the question was asked. So I don't know that that's where I would put my confidence. Secondly, it says a separate independent survey where only 500 people participated. 38% of them said that the United Nations should move out of the United States. Well, it's a much, much smaller sample, but it was independent, meaning there was less room for bias, and randomly selected. I think those are golden words, right? randomly selected. So anytime we see that there's random selection, there's a much better chance that whatever we find in that sample can be translated to a certain degree to that entire population that we're trying to make some conclusions about. So this next slide says pretty much that regardless of the sample sizes being very different, it's actually the sampling technique that is going to be playing a bigger part in why those numbers are so different. So how a study is organized and planned out in advance can make a huge difference in the results and therefore in what we do with those results. Once we've collected the data, however, it's time to kind of crunch the numbers and put the information together in a way that we can understand it. A good way to do that is to put the information in some sort of table or graph so that we can visually see what is happening with the information. A good statistical analysis, however, doesn't require a lot of number crunching. A lot of analysis is about making sense of what we see and drawing conclusions using common sense. So in this course, we're definitely going to have some calculations. There will be some formulas. We will use the calculator to do a little bit of the number crunching, but really the best use of our thinking power is not going to go to the calculations. It's going to go to what we do with those results, right? If we find after crunching numbers that the mean of a data set is 18.2 and the standard deviation is 1.6, okay, that's great. What does that mean? And what does that mean for any decisions that need to be made that come from those results? Lastly, in the process, once we've collected the data, analyzed it, now it's time to assign some meaning. Now it's time to draw some conclusions. So the final step in the statistical process is to draw conclusions. Now, the word significance in statistics is going to be very important. Significance means that it was worth the trouble and that these results are providing us enough evidence of some phenomenon. But there are two different types of significance. Statistical significance is one thing. Practical significance oftentimes is something completely different. So let's talk a little bit about the difference between statistical and practical significance. Statistical significance means that the result is very unique in the sense that we don't think it was a fluke. We don't think it happened just by chance. We think it truly reflects a phenomenon that is there. And so you're going to see that a lot of times we're going to assign statistical significance to results that have less than a 5% chance of having occurred by chance alone. And we'll get more into that throughout the course. You don't need to struggle too much with making sense of that statement for now. But the easiest way to remember the difference between statistical and practical significance is that statistical significance is tied to a probability. It's tied to a number, a percentage. So for example, if we have 98 girls out of 100 births, so 98 girls and 2 boys. After some number crunching, I think we're going to find that those are statistically significant results because having 98 girls and only 2 boys out of 100 births is not likely to come from chance alone. If that is happening, we need to dig deeper to see why that is happening. I think it's more to be expected that roughly half would be girls and roughly half would be boys, because very close to 50% is the probability of having one gender or the other. So getting 52 girls out of 100 births, that would not be statistically significant because we kind of expect that. So statistical significance is something that is kind of a unique result, something that has a probability attached to it that is rather low and not likely to happen by chance alone. Practical significance, on the other hand, has to do with impact. It is possible that some treatment or some finding is statistically significant, but that doesn't mean that the results are really that impactful to the world. I'm going to give the example that I often give in the classroom. Let's say that we run a study for a particular weight loss regimen where the participants have a very, very strict diet. They have a very strict physical activity regimen, and they're going to follow this program for 12 months. So the strict diet, the strict physical activity regimen, they're going to do that for 12 months. And let's say that after 12 months, everybody's pre-program weight is compared to their post-program weight. And of course, the goal was weight loss. And let's say that without much room for doubt, we can confirm that the average weight loss for these participants was 2 pounds. Well, there was weight loss. The program did what it said it was supposed to do, but hopefully you're kind of scratching your head and saying, wait a minute, 12 months of a very, very strict diet and very arduous physical activity regimen for 2 pounds, that would really disappoint me. So that is an example of, we can have really strong evidence of the 2 pounds being lost, but the result is not impactful enough to make that a phenomenon that we would really consider to be striking. This next slide pretty much uses the example that I went through, just with more numbers. It's just very intimidating with all the words. So pretty much what I said in the previous slide. In this slide, we have kind of just some things that we need to be made aware that are potential pitfalls for data that is collected. The first is, when we talk about a finding, when we talk about a conclusion, we want to make sure that we communicate that in clear terms that anybody can understand, whether they understand statistics or not. And I think a lot of times we have reports that have so much jargon and have so much terminology that people can't relate to, that people don't understand what those results are. And unfortunately, that's not unintentional. I think that's very much on purpose. So making sure that you're speaking in clear terms that anybody can understand is really important. The other is self-reported data. Self-reported data typically is not very dependable. I remember I used to teach statistics at the high school level many, many years ago as an advanced placement course, and we had the students produce their own survey, and then we got permission from the school principal to go out and distribute that survey. And one of the survey questions was, how many sexual partners have you had? Now, may I remind you, this was high school. When we got the results of the survey back, my students were perplexed and some were horrified. Some of those responses were 1,000, 1,000,000. Well, we hope those aren't true. We hope that people were just trying to, have a good laugh. But when you have self-reported data, you really don't have a way of verifying that information, so you have to take people kind of at their word, and that makes it unreliable many times. Next, loaded questions. The way I ask a question could absolutely influence how you answer it, because I'm going to be open to swaying you in one direction or the other. I'm sure you can think of examples where someone has asked you a question and they're telling you exactly which answer they're looking for. So this is what we call bias in the wording of the question, or loaded questions. And also the order in which we ask questions could affect the responses. Non-response refers to when we are asking for information, but the person we are asking the information from chooses not to give it to us. Of course, that can affect the overall results, because as with my Amazon example earlier, if you choose not to respond, there could be some commonalities among those who choose not to respond. You could be opposed to the survey. You could not find a reason to respond. So the non-response issue is just something to be made aware of as we study data. Also, there could be very low response rates. When you don't have a lot of participation, that also could mean that there's kind of a hidden story behind the numbers. And when it comes to percentages, people unfortunately will use the lack of knowledge in the general population, and by population I mean just the human race, to say things in a way that would lead any person to reach a certain conclusion when really that's not what's being said. So when it comes to percentages, not a lot of people understand percentages. Not a lot of people could really make sense of what numbers mean, and so that could be used to the advantage of whoever is presenting the data. So this is the end of the first section with some statistical and critical thinking. Hopefully this opened your eyes to how you ingest information, how you take in information, and hopefully as you are given information in the future, now you have a list of questions that you should be asking yourself that will hopefully open the door to what you do with that information.